Saxon Algebra 1/2. Lesson 114. Remember lesson 113 in which we just measured things on pictures of rulers in the book and we didn't have to write anything down? That was fun, right? Lesson 114 is also fun. The topic is probability. Okay, we're just going to take the ideas that we learned last time and we're going to bump it ahead just a tiny bit. It's not hard, it's fun. Okay, we talked about probability as something that you can measure from what we call events. Games is another word you could use, but the events we talked about were flipping a coin, spinning a spinner, you know, like I think Candyland has one like that. I know Hi-Ho Cheerio does, you know, where you flick it and you spin. Rolling a dice, or a single one is a die. Two or more are called a dice. Picking a card. Those are all what we call events. In probability, true probability, events are independent. This is I spelled that wrong. It's so wrong. Independent. There, now I spelled it right. Indent, that's not what I meant. Independent, meaning you flip a coin and you get heads. That doesn't change what's going to happen next time you flip the coin. Getting heads once doesn't make it more likely that you'll get heads again, nor does it make it more likely that you'll get tails. Every flip is unbiased by anything else, right? Same thing for rolling a die. If the person before you gets boxcars, double sixes, that doesn't mean you can't or you won't. It just means that every time a person performs one of these events, the previous events and the future events are unaffected by each event. Okay, so what that means is that we can find the probability of multiple events. Oh, let me just write down this. The probability of any event, like flipping and getting heads or drawing the ace of spades, we can calculate it by taking the number. Remember, hashtag used to mean number. It still does. The number of desired outcomes, right? If you're talking about the ace of spades, there's only one ace of spades in the whole deck. And then you divide that by the number of total possible outcomes. So in our example, the probability of drawing the ace of spades, that's the event. There's only one ace of spades in a deck of 52 cards. Okay, so there's just an example to remind you of how this works. All right, so let's take the example of flipping a coin. This is example 114.1. Okay, and we're gonna flip it 3 times. 1, 2, 3. Now, we know that each of these events is independent. They don't affect each other, but we just want to know what are the odds of getting 3 heads in a row. So the probability of, this is how I like to write it, heads, heads, heads. Okay, we find out what's the probability of getting heads in the first event. Well, that's 1 out of 2, right? What's the probability of getting heads in the second event? Also 1 out of 2, right? 1 heads out of heads or tails. 1 heads out of heads or tails. And same for this one, 1 heads out of heads or tails. They're all independent, so they all have the exact same probability. We want to know the probability of all 3, so we multiply, and we get 1/8 as the probability of getting heads 3 times in a row. Okay, so we just set up the independent events and we multiply them. Oh, that's fun, right? All right, and now here's a trick one. I mean, it's not really a trick. It's just testing you on your knowledge. A fair coin is tossed 4 times and it comes up heads each time. Okay, so we can draw a little picture of that. 1, 2, 3, 4, and it comes up heads, 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 heads. What is the probability that it will come up heads on the next toss? Okay, so we're trying to find the probability of 5. Now, there's some little part of our brains that wants to say, look, it came up heads 4 times in a row. It's got to be tails, right? I mean, you got to get tails sooner or later. Yes, sooner or later, but these 4 events do not affect this 5th throw. Again, because they're independent events. So the odds of getting heads on the 5th try are 1 out of 2, just like every other time we ever flip a coin, right? In the aggregate, meaning, you know, over hundreds of coin tosses, you're going to get really close to that 1 out of 2. You're going to average that, but it might be out of average, right? We might get heads again. We might have 5 flips in a row that are heads. That doesn't change anything, though. That just means we're on a roll. Okay, that's all. So don't be tricked by these questions that tell you about what's happened in the past. Each event is independent and it is unaffected by prior ones. This problem is a different scenario because we're not saying anything about how they affect each other. We're just trying to find what are the odds of 3 independent events going a certain way. Okay, that's all. Goodbye.